Good morning, guys. Anjani Kumar here, leading instrumentation subject for final year electrical students. Right. In the last session, we discussed about signals and the representation. Right. So I'll just remind what you did in the last session. Right. So what we completed: the signals and their representation. Right. So what is meant by signal? Signals means which can carry the information. Right. So signal is nothing but which can carry the information. So whatever the information it is, either physical information, right, or electrical information, and all these things, right. So it depends on a time value. It can be that signal which can vary with the time itself, right? So if you know the time, you can easily find out the frequency of the signal. So how much frequency of the signal that is having. So that we can easily define. So what is meant by signal? Signal is nothing but which can carry the information, right? So these type of signals that can be vary with the time. It's a time dependent. So if you know the time, you can easily predict the frequency of the signal. So whatever the examples, those are electrical signal, right? Power signal, human voice signal, and all these things. These are the examples of the signals. Next, what are the standard test signals? Standard test signals. We discussed. So what is the standard test signals? So these are the signals we can easily generate in the laboratory. That means if you want to predict any system performance, we need an input signal. Right? So what type of input that you are giving to predict the system output? So for this we require a signal. So definitely if you want to easily predict the system, these type of signals we can easily generate in the laboratories. So if you want to test any system, we just apply these signals and definitely will get the output. So from this, you can easily explain the performance of a system. Right? So what are that means easily generated in the laboratory itself. If you go for a sine wave, it's very difficult to generate in the laboratory. We require an inverter. It should be a cost based, right? The frequency won't be a constant value. So time to time, my output goes on, changes. So for this, we have signals, so that can be easily generated in the laboratory. These type of signals we can apply to the instrument. So with that, you can easily predict the performance of any system. Right? So what are the step signals? What are the standard test signals? So what are the standard test signals? We already discussed about these things, right? Step signal or unit step signal. Next, a ramp signal. Alright, unit ramp signal. Parabolic signal. Unit parabolic signal. And the fourth one is impulse signal. Unit impulse signal. Right, these are the signals we can easily generate in our laboratory itself. So with this you can directly apply to the system, will predict the performance of each and every system. Right? So what is a step signal? So I'll briefly explain one more time. So what is a step signal? So step signal means it's look like this. This is the time. This is my output magnitude. Magnitude is A. Right? R of t is equal to A. That means constant value for a t greater than or equal to 0. Equal to 0, A, 1, A, 2, A. That means R of t is equal to A for t greater than or equal to 0. So t less than or equal to 0, is there any response? There is no response. So for t less than 0, it should be 0. Right? So this we can call it as a step. If you go for a unit step, in place of magnitude A, you can put it as 1. So for this, R of t is equal to 1 for a t greater than or equal to 0 is equal to 0 for t less than 0. So this is a response of a unit step signal, right? And I'll go for what is a unit ramp signal. Alright, unit ramp signal. What is a symbolic representation? Ramp means linearly varies with time. Right, if it is a time, this is my output. Right, for 1 you have a 2, for a 2 you have a 4, for a 3 you have a 6. All these things. So these are linearly varies with the time. Right. So that means the notation is R of t is equal to AT for t greater than or equal to 0. Alright, is equal to 0. Is there any response? That means 0 for t less than 0. For a unit ramp, R of t is equal to t for t greater than or equal to 0. Equal to 0 for t less than 0. So that's for unit ramp signal. And after that, so what is the relationship between these steps? You know about it. So integral of step signal. That means integral of what is a step A. So what is the value AT? So what is this one? A ramp signal. Right? So integral of step signal is equal to ramp signal. So this is important note that we discussed. So these are the things that we discussed in yesterday's class itself. This is very, very important question. So integral of steps, from here you will see integral of step. What is a step? A. So what integral of A, AT with respect to time, each and everything with respect to time, because my input is a time, right? Right, what is AT? AT means a ramp signal, right? AT means ramp signal. So integral of step signal is nothing but ramp signal. Very, very important question. Right, this is about step signal and this is about ramp signal, right? This is a step, this is a ramp signal. Now we'll discuss about parabolic signal, right? How the parabolic signal look like. So the parabolic signal, how the parabola shape, we already discussed in your intermediate stage, how the parabolic, so curve shape. So if it is an output, this is a time. So this is a time. Time varies 1, 2, 3. Whatever it may be, 2, 4, 6, 8, something, whatever it may be. Alright? 4 means 5, 6, whatever it may be. So R of t is equal to, what is the fundamental equations? R of t is equal to, what is the parabolicity? Y is equal to mx square. 4a square in a parabolic. 8 square by 2. 4 t greater than or equal to 0. And is equal to 0. Is there any response less than or equal to 0? For t less than 0. For a unit parabolic, so what is the equation? R of t is equal to t square by 2 for t greater than or equal to 0, equal to 0 for t less than 0. Alright, now this is about a parabolic signal. Now we'll go for impulse signal. So what is meant by impulse signal? So impulse signal means at 0 time you have a maximum value of a magnitude. At 0 time you are getting maximum value of a magnitude. That means how the signals will look like. Right? That means at time t is equal to 0 you have an infinity magnitude. After that you don't have any response. Right? At 0 time you are getting a maximum magnitude. Is it possible? So definitely not possible. So that's why it's very difficult to generate in our laboratory these type of waveforms, right? So what is that value? So it can be denoted by del of t. So impulse response is del of t. So del of t is equal to infinity when t is equal to 0. At t is equal to 0, the magnitude is infinity. Right? And is equal to 0 at t not equal to 0. At any place you don't have any response, either less than 0, greater than 0, whatever it may be. Right? At t is equal to 0, the magnitude of impulse is infinity. Is equal to 0, t is equal to t not equal to 0. So this is the response of the impulse impulse signal. So it's very difficult to generate in our laboratory these type of impulse signal, because 0 time low maximum magnitude it's not possible, right? For suppose if you have these type of impulse signal in your hand, it's very easy when compared to other signals. It is very easier to predict the performance of the signal. You know about what is the transfer function? Laplace transform of output by Laplace transform of input na. So what is the Laplace transform of impulse signal? 1, right? If you want to, right, so if you want to predict the performance, whatever the output that you have, that's my transfer function, because my Laplace transform of input is 1. Make ఏమైతే output వస్తుందో, that is my response. Alright, so that's why these type of signals we are not used anywhere, right? So these are we discussed about how there is a relationship is there na? And after that and now we'll see the relationship, right? So integral of ramp signal, right? So what is a ramp signal? Integral of AT na. So integration of AT, so you can calculate AT square by 2. So what it is? It's a parabolic signal. So integral of ramp signal is a parabolic signal. Integral of ramp signal is a parabolic signal. So this is another statements that we got. I will explain in the last session also. I will explain one more time, because this is very, very important concept. So what the statement says. See, integral of step signal is ramp signal, right? So integral of ramp signal is parabolic signal. So this is one type of statements that you got. Or else, if you want to remove this integral, you have to derivative. So both side you apply derivative. So d by dt, d by dt. So d by dt, d by dt. So this d by dt, this integration will get cancelled out. This d by dt, this integration will get cancelled. Now we will define one more equations. So derivation of ramp signal, you will get a step signal, right? Or else derivative of parabolic signal, you will get a ramp signal. This is one more equations that you got. This is very, very important bits. Definitely you will get questions from this. So that means integral of step signal is a ramp signal. Integral of ramp signal is parabolic signal. If you apply a derivative, so derivation of ramp signal is a step signal. Derivation of a parabolic signal is a ramp signal, right? With this we completed one type of a signals, because these are elaborate generated signals, right? Now we'll go for another type of a signals, right? Sinusoidal signals. It's very difficult to generate in our laboratory itself, right? So basically, there are two types of a signals. You just listen carefully. This is very, very important things you need to understand, right? Basically, there are two types of signals with respect to types of signals. So those are continuous time signal and discrete time signal. So what are those? Continuous signal and discrete signal. So what is a continuous signal? So what is a continuous signal? So continuous signal means continuously vary with time. That means continuously varies with time. So at any point of time, you'll get the magnitude of a signal. You get the value of a signal. At any particular time also, you'll get the magnitude. So that means continuously varies with time. That means at any particular value, you can define a magnitude of that signal, right? For suppose so this is a continuous signal, right? For suppose the value is 0, 1, 2, 3. At 1 the magnitude is 2. At 2 the magnitude is 4. At 3 magnitude is 6. Right? So the continuous signal. So if you want to find 1.5 at time 1.5, what is the value of? Definitely you will get the magnitude. 1.5 means here. So whatever the value of here, you can find out the magnitude. Alright? So or else 2.3. You can easily get because you have a magnitude value here. Right? For a 3 or all these things. That means continuously varies with that time. At any point, you can define a value of a signal. Next, what is a discrete time signal? So the discrete interval of time, right? At the discrete interval of time, that means how the signal look like. 2, 4, 6. Alright, 0, 1, 3, 6, 7, 8. Alright, that means this is a discrete, not continuous. For suppose there is a value. If it is a 1, what is the output? 2. If it is a 3, what is the output? 4. If it is a 6, what is the output? 6. For suppose if I want to find out the value of 2, so at a time t is equal to 2, what is my signal value? You don't know. So t is equal to 2, you have any signals here? There is no signals. At time t is equal to 2, it's very difficult to find out the amplitude of a signal. Right? So these type of signals we can call it as a discrete time signals. Right? I think, I hope you people understand what is a continuous time signals. At any value, any particular of time, you will get the magnitude of a signal. Right? Discrete time means whatever the mention points, only you will get the magnitude. Other points you won't get. Other points of time you won't get the value of a magnitudes. Right? Discrete interval of time. So what are the examples? These are the examples. Ramp signal. That means ramp signal. Parabolic signal. Ramp. Parabolic. So these are the important. These are the examples for a discrete time signals. For a continuous time signal, so what is this is nothing but sine wave. So what is a period? We will discuss in a following session what is a time period. In a continuous signal, the period can be represented by t. The period can be represented by t. In discrete time signal, the period can be represented by n. So very, very important bit. Right? So there are two types of a signal. So what are the? So there are continuous signal and a discrete signal. So continuous signal means continuously varies with the time. At any particular instant of time, we'll get the magnitude of a signals. Right? Discrete signals means discrete interval of time. That means particular value of a particular time only you will get the magnitude of value. So other times you won't get the value. Right? So these are discretely varies with the time. So what are the examples of discrete time signals? Those are ramp signal, parabolic signal, and all these things. Right? Now we'll go for periodic signal and aperiodic signal. Very, very important. Now we'll discuss about a periodic signal and aperiodic signal. If the signal is a period, what is a time period? If a signal is not period, you will check whether the signal is a period or not. If it is a period, what is the time period? You have to find out for a continuous time signal and discrete time signals also. So for this we'll start what is a periodic signal and aperiodic signal. Periodic signal and aperiodic signal. So what is a periodic signal? So periodic means the signal which repeats for a particular interval of time. So that means a signal which repeats at particular interval of time. So we can call it as a periodic signal, right? Mathematically, if the signal given input, if the signal x of t is a periodic, so that means it satisfies x of t is equal to x of t plus t. If it satisfies this thing, then the signal is a periodic signal. That means the signal which repeats a particular interval of time. That means, if you see, right? So this is a signal, right? So this is a signal, and the period is t. One positive half cycle, one negative half cycle. We can call it as a t. The same signal which repeats for another time t. This is also time, so that we can call it as a 2t. Alright. Once again, the signal will repeat itself. So this is called 3t. That means the signal which repeats particular interval of time. So what is that interval of time? T. This is t, this is 2t, and this is 3t. So this type of signals we can call it as a periodic signal. That means if this signal is x of t, you are assuming that after t plus t, that means t plus t, t ni add chesna, you are getting the same signal. So this is also x of t now. Right, and to t plus another t. So whatever this, you are getting same signal now. That means this is the condition, x of t is equal to x of t plus t. T is nothing but time period. Time period means lowest value of a time. This is t now. This is 2t now. 3t now. 4t now, and so on. Right. The lowest value of a period. The lowest value of a, what I said, signal which repeats at a particular interval of time. The lowest value of the time we can call it as a time period. So what is the time period here? T. Highest value, these are 2t highest value, 3t highest value, 4t highest value, right? T, 2t and 3t. And again, if another wave is there, so this we can call it as a 4t. The lowest value of time, this is the t. So this we can call it as a time period of the signal. Right? I hope you understood. That means what is a periodic signal? If a signal is said to be period, means which repeats for a particular interval of time. Right? Particular interval or a period of time. Particular period of time. If x of t is said to be a periodic signal, it satisfies the x of t is equal to x of t plus t. So here t can called as a time period. So what is the time period? The lowest value of a interval of time. The lowest value of a time we can call it as a period. T, 2t, 3t, 4t. The lowest value is t. So that we can call it as a time period. If you know the time period, you can easily find the frequency of a signal. So what is that frequency? 1 by t. So we can call it as a frequency of the signal. So periodic, what is if the signal is a period, that means you have to find out what is the time period. At what time period that signal which repeats itself, right? So you have to find out the time period. Right? This is about periodic signal. If the signal which doesn't satisfy this one, that means that signal we can call it as a aperiodic signal. That means it doesn't repeat for a particular interval of time. Goes on, looks like. For suppose the signal is look like. So this is a aperiodic signal. That means you don't have any time period for this one. Right? So which doesn't satisfy, then we can call it as a periodic signal. Signal which repeats itself for a particular interval of time, particular period of time, that we can call it as a periodic signal. And after that, if it doesn't satisfy this one, we can call it as a aperiodic signal. And some sort of conditions is there which we have to discuss here. If the signal which is having a same frequency, if two signals which are of same frequency are added, if the signal, that means that is a periodic signal, whatever it may be, if the two periodic signals which are the same frequencies, but that means this is a sinusoidal periodic signal, another one is a sinus, this is 1 megahertz, this is 1 megahertz. If you add, you will get the sinusoidal. If it is a periodic signal, this is also periodic signal. If you add, you will get the resultant will be a periodic signal. This is one important question. If two signals, periodic signals which are added, the same frequencies, periodic signals which are added, then definitely you will get the output must be a periodic signal. Right? Periodic signal. Or else, if two signals with different frequencies which are added, then may or may not be a periodic signal. Right? So what is that conditions? What is that note? If two signals, that means if two signals, periodic signals which are added with same frequencies, then resultant will be a periodic signal. If two signals of different frequencies, if those are added, the resultant may be or may not be a periodic signals. Right? So this is about periodic signal and aperiodic signal. Right? In the next session, we will discuss about conditions. So if it is a continuous signal, what are the conditions to check whether the signal is a periodic? If it is a periodic, what is the time period? For a discrete time signal, so what is if it is a signal is a periodic, and what is the time period, and all these things we'll discuss in the next session. Alright, and I think up to now it's clear for you guys. Thank you very much.